Good morning, everyone. What I'm going to go over today is a small game I put together. And I've just been adopting everything over to Python 3 and using MX Linux for my course. I learned on Python 2. Of course, there are differences when, especially doing string concatenation, that sort of stuff. So I've just been working on putting together a new training program for the different DEF CONs and cons across the world that I'll hopefully be attending this year. Um, I'll jump right into it here. Here's our game. It has an input that we can put input into the buffer. We have a variable z with a 0 that's set to 0, and our buffer is 50 bytes. The stir copy, of course, does not do bounds checking, so this is vulnerable to exploitation. And this basic little program just says basically if z is not 0, you've completed this challenge, z is now whatever it is, else you suck, x is still 0. And then a simple return to libc start main. So that's the simple C program we're going to play with today. And it's basically just to get used to putting things onto the buffer. My last two classes have just been about finding variables on the buffer and how a stack works. Now we're going to see how input is stored onto a stack and how we can overwrite things. Overwriting things is um, a basic skill you need to get before you get into exploitation of the stack with shell codes and stuff like that in some vanilla buffer overflows. So we're slowly working our way through here. Um, so that's that. Let's jump into our terminal where we live. And I'm in my binary folder here. And I already compiled the game program is F no stack protector, no pi, and then just game.c and output game. Okay. So what I'm going to do, I'm going to use Jeff today, and I showed everyone how to use the different plugins like Jeff and PETA in a previous video on setting up our exploit lab. So you can check those out. But we're going to use Jeff today. And the first things first, we're going to disassemble the main function. And as you can see from our past two, this is quite an extensive program compared to the little ones we've looked at. First things first, we need to identify this stir copy. Here's the vulnerable function. And right here, this is where the program is going to copy our input onto the stack. So I'm going to set up a breakpoint right here. There we go. So what I'm going to do, I'm going to run it. I'm going to put some A's in for input, and we'll see, we'll track down Z on the stack, and then we will attempt to overwrite it. So this is just some basic skills to do some buffer overflows, and this is just the lead up to it. So we're going to run, and I'm going to put in 10 A's. Okay, so I don't like, Jeff, that I can't put in just display 60 words of hex from ESP and just have it come up every time like in normal GDB, but it does provide you so much more. And we'll get into using Jeff, the different parts of Jeff once we get into some more advanced exploitation. And here's the stack. So let's find everything on the stack first. Of course, we know where our ESP is. It's up here in the top corner at B0. So there's our ESP. Let's find our EBP. Where's our base pointer at? It's at 008. So we come down here 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Because remember, we start at 0 as we count over here. So here's 8. Here's our base pointer. And of course, what's next to our base pointer? This would be the return function, to return to libc start main. So we can check that out by doing examine words in hex of this motherfucker. And as you can see, libc start main call. So right next to it would be our argument count, and this here is our argument vector. So this here is our full stack. Now let's try to track down this Z. So I'm going to give you another command we haven't used in GDB yet, and that's print the address of Z. And as you can see, it's at EFFC. So E, F, F, and now C. So it's at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why 12? Because we're at C. You need to learn hex, and it just comes natural after a while. But A is 10, B is 11, C is 12. So 12 from this place right here. This is our Z here. So we need to overwrite this buffer right down to here to get the program to work. I'm going to hit next instruction, and now we're at stir copy. So now our input that we put at the beginning of the program is copied onto the stack. So let's do another display of 60 words in hex. And as you can see, here's our A's here, 41 in hex, and it's covered these right here. So of course, we're going to need a lot more A's to get this. So we need 1, 2, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So we're going to need 44 more bytes to cover that up. So this is pretty simple. So let's continue on the program here. And as you can see, continuing, you suck, X is still 0. We didn't overwrite it that time. So now we're going to do a little bit of Python here. And this is something I'm happy with my new program here, because so many of the programs out there are still using Python 2 and older Ubuntu's and stuff, and it's really great for learning. But when you want to get into something new, you need to adapt to new Python 3. Python 3 is a pain in the ass because of the concatenation problems with strings and stuff. So yeah, so we're working through it here. So now we need to put a print statement in, and we need to put in our A, and we're going to say times 50 and close it here and put a tick and close it again. So this is a little different in Python 3, but this is the way to do it here. So now I'm going to run the program with that that input. Then we're going to hit next instruction, which brings us to our 4 ones placed onto the stack. And as you can see, 50 takes it right before our Z. So we haven't overwritten it with 50, but we're almost there. So I'm going to continue on here, and you suck, X is still 0. Okay, so now I'm going to go back to run the program again, and let's put in 52 A's. And I'm going to hit next instruction. Let's display 60 words of hex from the stack pointer. And as you can see, let's do print and Z, this address right here. And as you can see, we have 2 A's placed on this 4 byte word in 32-bit. So that's great. We've overwritten our Z. So let's hit continue. And as you can see, you have completed this challenge. Yay! Z is overwritten with 4141. So what I hope you got out of this is how inputs work on stacks, how to find variables on stacks, and how to overwrite things on the variable. It also gives you a bit of look into calculating the size of a stack and how to fill it up. Now, there's easier ways to do this. I've even written a program for it that does it for me. But this, we got to walk before we run. So this is the stuff I wanted to show you today. I hope you enjoy. I'm slowly building out my training program for conferences for this year, and it's going really, really good. So I hope you enjoy this. And if you do, please share, and I shall get back to you guys later on this week. Bye, guys.